Today we're going to begin with the concept of molarity. Molarity is a quantitative evaluation of the concentration of a solution. Earlier we talked about qualitative ways of expressing that, like saying that a solution is concentrated, or a solution is diluted, or it's dilute. But now we're going to actually place numbers, have a quantitative value to the concept of concentration. So let's look at the first problem. It asks to calculate the molarity of the following solutions. Well, it's important before you do that to remember what molarity means. Molarity means, first of all, it's expressed by a large M, and it means the moles of solute over the liters of solution. And so let's begin with the first one. I wrote this kind of funny. It's solute. Okay, and this should be liters of solution. Remembering that when you make a solution, you always put first the solvent in, some of it, into a volumetric flask, and then you place the solute in there. You have to pre-measure it depending on the concentration that you'd like. And then you add the solvent, typically water, to the calculated line on the volumetric flask, and that's usually a 1 liter solution. Sometimes you need more, sometimes you need less, so that's why we have to do these calculations. Okay, let's say, for example, we have 2.3 moles of sodium chloride. Sodium chloride is a solute, so we say we have 2.3 moles of that. And then it says we have a 0.45 liters of solution, so that's 0.45 liters of solution. And so this one's rather easy because molarity is expressed in moles per liter of solution, so all we have to do is divide, and our answer comes out to be 5.1 moles per liter solution. And if you were to write that on a container, and you needed for people to know the concentration of that solution, you'd put 5.1 moles, which would be a large M expressing molarity, of NaCl. That's easy. Okay, let's try the second one. We have 1.2 moles of calcium carbonate, and the solution is a 1.22 liter of solution. So we're going to have close to a mole because these two numbers are so close. I mean, 1 molarity. 1.2 moles over 1.22 liters of solution. Again, that's expressing the definition, so all we have to do is divide 1.22 into 1.2, and our answer is 0.98 moles per liter of solution, and that ends up being expressed as 0.98 large M calcium carbonate. Okay, I am not going to work 3 through 5 because it's just the same process. I will give you the answers though, so that you're able to see if you got the calculation correctly. So 3 is actually 8 moles of molarity. Number 4 is 12. And number 5 is 0.2. Okay, now let's go down to number 6. Now, remembering the definition, molarity equals moles of solute, let's see if I can make this better than before, divided by liters of solution. Okay, so here we have 120 grams of calcium nitrate, and we have 240 milliliters of solution. Well, since the definition is moles of solute, we're going to have to start off converting that into how many moles we have. So it's just like doing all the molarity problems we've had in the past. I mean, not molarity problems, but problems of changing grams to moles. So start off with 120 grams of calcium, it's nitride, and we have to convert that, well, we can say that that's 0.24 liters, changing that 240 milliliters to liters. Let's change the gram value to how many moles we have. We know that a 172.2 grams of calcium nitride is a mole of it. And so now we've actually converted that to how many moles we have, and that gives us 0.70 moles of calcium nitride, and we still have the 0.24 liters, and so we're back to our original type of calculation. Dividing 2.24 into 0.70, we get 2.9 moles per liter, which is 2.9 with an M behind it to express molarity, and the solution is calcium nitride. Okay, as you can see, number 7 and 8 are similar. Remembering, of course, how to get the name for acids and bases. So try doing those and see if you come up with the right answer. The answer for number 7 is 1.1 molarity, and the answer for number 8 is 1.4 molarity. All right, good luck.